Hey there, everybody. Now that we've set the stage for structural programming from chapters 1 through 3, we have things like variables so that we can manipulate things. We have keywords so we can have a regular way to display to the next programmer in the chain what it is that we're trying to accomplish with our algorithm. And we have some basic pseudocode structure. We have things like, capital letters for our keywords, any and all indentation that we might do, naming of our programs with an end at the end of our programs. These are the first most basic steps. And essentially from here on out, with chapters 4 through 12, what we'll do is keep adding one new wrinkle of complexity, and each one of those wrinkles really goes through and adds a lot more functionality to just how it is that we will be assembling our programs moving forward. So here in chapter 4, we're just going to add our first layer of function and complexity to things with selection. What it boils down to is selection allows you to make a decision. So everything we have done to this date has been essentially concrete sequential. There are no deviations. We go steps 1, 2, 3, 4, 5, and there are no alternative measures to be taken. Now, that works for some things. Actually, it works for some processes and procedures incredibly well. Oftentimes, actually, when you put a process or a procedure together, what you want to do is remove the amount of decision, remove the amount of alterations that the data or that the user can actually undergo. When you do that, what you do is you ensure that by forcing the user to comply with your system, you are ensuring that your system works a higher percentage of the time. And who doesn't like a product that works most of the time? But that's not really feasible in most interactions that you have with a program or with a procedure. You are going to require the user, or you are going to require of the data to force your program along an alternative path based on those kinds of decisions. So selection allows you to make a decision. So here are some things that you are going to need to make selections. First and foremost, you are going to need something tangible to test. Decisions make the most sense when it is a concrete thing that you can tell that you're making a decision on. If account balance is greater than 300, that's a tangible number. If button 7 is pressed, that is a tangible action. If on button is pressed, tangible action, as opposed to a non-tangible action. Those are a lot harder to point at. They are certainly something we don't want to have here. There's always, hopefully there's always, in the way it is that you structure your program, there is an easily discernible alternative between things. Mathematically is best. So even if it takes you 1 or 2 additional steps to be able to make a mathematical kind of an equation out of things, that is best. And we're going to see examples of that as we go through with the in-class examples for selection. Next, after something tangible to test, we are going to need an alternative set of directions if necessary. It's not enough to say, if bank account is greater than 300, take this action, and then leave what the alternative action would be. So with everybody who has an account balance of $299.99, your organization has to wait. There is no instruction set there. And that's a huge potential for error because when it comes time for that code to actually be running in a selected environment, the environment is going to treat that if as though there is no alternative. So it will essentially ignore customers with a less than $300 balance. And that can be a huge issue. Certainly it's a huge customer service issue, but it could be a legal or an ethical issue depending on what kind of program, what kind of industry it is that you are in. So if you are specifying that there should be an alternative action, actually go through and specify what that alternative set of directions should be. Next, we need a structure to ensure that when we have a whole set of different decisions to make, that the program can follow along. Oftentimes, we're not doing what is known as simple selection, just two alternatives. You either have more than $300 or less than $300. We want a whole range of decisions that we can make. So if you have more than $300, if you are in a certain zip code, if you have a certain kind of loan, or if you have a certain kind of credit score, etc. In those cases where we have multiple different decisions to make, what we want to make sure is that we are following along with a structure that allows the next developer in the chain to see, okay, these pieces of the decision are coupled. They're actually grouped together. Whereas other pieces of the decision belong separately from this. And these are things we're going to see here throughout Chapter 4. So what is the keyword? What is the keyword structure that we're going to use here? We are going to use if, else, and end if. A couple of words of note here. Because they are keywords, and as always with our keywords, all keywords are capitalized. So if, else if is one word, else and if, another one word keyword. Those are all in caps. You don't always need more than an if and an end if. So for every if you have, it is going to be guaranteed that you will have an accompanying end if. You oftentimes will find that there are no alternatives for something. You're simply checking against one condition, and there's really no alternative action to take. In that case, you don't need an else if, or you don't need an else. But even in those situations where you have an if, an else if, an else, and an end if, all of which we will get into, they always appear from top to bottom on the same vertical line. So here, if you refer back to your pseudocode style worksheet, you can actually see the way it is that we indent things. A note on indentation, as is most often the case, there are two equally fervent camps of how correct indentation should be done. One camp suggests that you should tab things over. So when I have nested, they're referred to as if statements, which we're going to see here shortly. When we have nested if statements, those subsequent ifs get one tab over so that we have a clear visual distinction from the if and it's connecting else if and it's connecting else. Otherwise, things get really messy really quickly. The other school of thought is tabs are dangerous. And a little bit of background here on why tabs legitimately can be a little bit difficult to work with. A tab we're all familiar with, right? So if we go into Microsoft Word, we expect that when I hit the tab key, I'm going to see an indentation of a specific length in my whatever it is, a paragraph or what have you. If I am using, an email to set up a really generic looking, almost an Excel spreadsheet, right, where I have rows and columns of data, and I just really quickly and cheaply want to put together something that looks like a spreadsheet, I can use tabs to do that, right? So I would put, January tab, February tab, March. Next line I would go 1 tab, 2 tab, 3, and keep going that way. That all works great. But in programming environments, those tabs are not always the same width. So what ends up happening is if you code your pseudocode in one particular language, or even worse, if you code your actual code, so in whatever its destination programming language is going to be, into one particular piece of software, and then you go to another one, that tab might not be the same width, and it doesn't seem like that would be a big issue until you see a big, huge block of text. Then, when you have these really unusual indentations there, the tab can be a big problem. So if I'm importing from Visual Studio on one side, I'm taking Text Wrangler on another, I've got Xcode coming in, and I've got brackets, another coding environment coming in, and they all have different tab indexes, so tab widths. It's going to be really difficult for that developer who has to put all those 4 disparate coding environments together to see what is happening when they're actually looking at things, because one tab might be 2 tabs in another coding environment. What is easier, what is better in their estimation, and actually this is what I would advocate for as well, is to use 3 spaces. So space, space, space. So you want to make another indentation, space, space, space. So if you need 3 indentations, you've got 9 spaces now. I can guarantee you are not going to burn up your keypad doing this. I have an extremely ancient Mac keyboard down here in my dungeon office. It is, if I had to venture a guess, I would say 17 years old, and the spacebar still works. So it has been with me through the entire of my coding career and a bunch of other people's coding careers. And actually, before that, it existed in a K-12 classroom, and I think it was a 3rd grade classroom, so they were pounding on it pretty good. So if all that life experience can't destroy a keyboard, I really doubt that we're going to be able to burn yours up. But I won't enforce one way or the other. So if you prefer the 3-space method, fine. If you prefer the tab method, that's fine too. As long as you're consistent within your code, that is the thing that I am the most concerned with. So make sure that if you have a selection in if with an accompanying end if, or if you have an if with a if, else, end if, or any combination thereof, that the if and the end if line up on the same vertical indentation. So that's the first portion here. The next portion we have to worry about are the comparison operators. A comparison operator gives your selection statement, your if, it gives you a way to be able to test for something tangible. So what do we have for that? We have less than, greater than, equals to. Those are the simple ones. With a little bit more complexity onto that, we have less than or equal to. That is represented by the less than symbol immediately followed by the equal symbol. We have the greater than or equal to. That is the greater than symbol immediately followed by the equals to. And we have the not equal to. Now, what I can tell you is for not equal to, either of the following 2 nomenclatures are perfectly acceptable. The one the textbook uses 99% of the time is the less than followed immediately by the greater than symbol. There's actually one example. It's in chapter 11. They must have gotten a new copywriter, and they let the next version in there. What you will actually see in most programming environments is not equal to being represented by the exclamation point followed immediately by the equals. Now, what I will mention, and again, I will not stick to a preference. As long as you are consistent, you can use greater than, or less than rather, greater than, or you can use exclamation equal to. However, in every programming environment, I am comfortable with saying this, that you are going to likely use. The not equals to is represented by exclamation equals. I would say if you are looking for a a muscle memory, if you are looking for a fair amount of certainty that when you develop your programs, that what we do here in CIS170 is analogous to what you'll see in the environments, I would certainly go with the exclamation equals to as opposed to the less than, greater than nomenclature. So now that we have those, let's take a look at the different kinds of selection control structures. So essentially all that means is what kinds of different if statements can we have? The first one, the easiest one to deal with, is a simple selection. That happens when we have a choice to be made between a total of two alternatives. So to use the account balance example from before, the simple one for this would be if account balance is less than 300, then something. If the account balance greater than 300, something else. The way we would represent this is we would have the keywords if and then on the same line. So those two keywords go together. Next, what we would have is whatever the following line would be there, we would have our action to be taken. Essentially what the program is going to do is when it comes to this line, if account balance less than 300, it is going to take a look at account balance, whatever is stored in that variable at the time. So in this case, let's suggest that it is $299. In that case, the account balance greater than 300 evaluates as false. Hey, the next line is going to be the line that the program is going to actually act on. So then the textbook here suggests that, okay, the service charge is equal to $5. So that's the first alternative. But what happens if, at the time that that if statement is being evaluated, let's suggest that account balance is actually greater than $300. So this time, the account balance comes through, and the number is $500. So you have plenty of cash in here. This time, the service charge is going to be $2. So what we need now is we need an else statement. So on the same vertical line, we would have if and else, and then indented. So again, your indent can either be one tab or it can be 3 spaces. You would have service charge equals, in this case, $2, because this time I have more money instead of I have less money. Next, what we would need is the end if. We have the end if here to signify that, hey, I'm done making selections. So this one is a simple if because we simply have 2 alternatives to choose from. Next up, we have what is known a little bit infuriatingly as the null else statement. So what that's suggesting is we have an if for which there are no alternatives. So, for example, if breathing, do not administer CPR, because inarguably there is no reason for you to administer CPR to an individual who is conscious, aware, and breathing, right? The only time it's appropriate to administer CPR is in the case that someone is not breathing. So there is no alternative to that, right? So there's nothing else I can do. So in those maybe peculiar times when there's no alternative action to take. I'm particularly burned by taxes. I was one time audited 3 years in a row for having spent in the first of those 3 years in additional $8 in taxes. Very strange but true. When is it that you are not sent tax forms? If deceased is the thing that we're looking for here. So if deceased, don't send tax forms. However, for everybody else, there's no other time when you're not receiving a tax form. So that works there. That's the null-else structure, where we're simply testing for a one-of kind of occasion, and for that one-of occasion, there is no alternative. Next, we have the combined selection statement. Here, we want to be even more specific in the kinds of selections that we're making. So in these cases, we are going to use the keywords and. The other keyword is or. I'm going to do what I can and fail miserably to not use the following statements: and, or, and I'm going to fail miserably. Those keywords, as with all of our other keywords, are going to be capitalized. How these are going to work is as follows. When we happen upon a selection that we want to make that is really contingent on more than one condition being met. So what we don't want to do is, let's say, for example, if we are taking student attendance. So this is actually something that we can see on page 39 of the textbook. If we are taking student attendance and we want to take part-time and we want to take full-time attendance. But we also want to be more specific. We want to take part-time female attendance and we want to take full-time female attendance. So the way we would do this is we would have a combined selection. We would say if student attendance equals part-time and student gender equals female, then add 1 to female part-time student count. So that is the combination we have there of the two. We have a record coming into our selection statement. So this particular record is student number 8675309. And we get the attendance code from that. Part-time. Fantastic. Our first selection here is true. So then it goes to the next statement to be evaluated. The statement there says and. Student gender equals female. Hey, fantastic. 8675309 is Jenny, and Jenny turns out to be a part-time female student. In that case, I'm adding 1 to the female part-time student count. The next student comes along, 8675310. This student is part-time. Hey, great. So that first portion of the statement is evaluated correctly. However, student gender this time equals male. In this case, that portion of the selection is false, and that student, 8675310, falls out. Goes down to the next portion of that statement, the else portion of the statement. We can put together as many of these combined selection statements as is necessary. So if I want to find, from a large data set, for example, I want to find part-time female students who live in the 61114 zip code, who have received scholarships in the past but have not received any kind of academic warnings. That's 5 different combinations I'm looking for. So clearly, each one of those combinations is going to help me reduce the number of possible individuals that I'm going to, for example, send a mailing to. So I take those 5 combinations and start whittling down my data. The thing to consider when we have an and statement is that both portions of that selection have to be evaluated as true. So the first portion of the statement, in this case, student attendance is part-time, has to be true. And the second portion of the statement, student gender equals female, has to be true. The other combined selection statement we have is or. In an or statement, only one of the 2 pieces of your selection have to be true. So let's go through that previous one again. We have if student attendance equals part-time. So this piece of data comes through here again. So it's 8675309, evaluates as part-time. Fantastic. And student gender, and this time we're going to say or student gender equals female, then add 1 to part-time female student count. So this one is still 8675309 is part-time student, and that is Jen. This is perfect. So yes, in fact, that is correct to add 1 to female part-time student count, just like we see here on page 39. Now, the next comes through. We have 8675310. And their attendance is part-time. So if student attendance equals part-time, evaluates as true. The next statement, or student gender equals female. So this time, Matt comes through here, and his 8675309 part-time student record comes up. Only one of the two of those has to evaluate as true. Student attendance or student gender. So what this is going to mean is that all female students are going to come through as part-time female students, and all part-time students are going to come through as female part-time student count because of that or statement. It is not to say that or is useless. There are plenty of instances where that's going to be okay. We're actually going to work through some in classes, and that's perfectly fine. And or is actually relatively powerful. You'll have more than one way to essentially to select on a given set of actions. That's great. However, it does require a little bit more thorough an investigation of, hey, am I right? I would actually far rather have to develop a little bit more carefully to have an and statement than to develop a little more quickly and have an or statement there. So the combination keywords are and or. They are uppercase, and see, I'm failing miserably at not being able to connect without actually using the keyword here. Both of those keywords give you an opportunity to make even more granular selections than a simple if statement would have been able to give you. Next up, we have a linear control structure. If you think about student grades, you have a really good sample of what a linear control structure looks like. In that case, we are using if statements to give you a grade. If you think about it, there are only 7 different grades. I believe it's 7 different grades that you can get. An A, a B, a C, a D, an F, an incomplete, and a withdraw. So those are the only 7 record codes we have for you as far as grade data goes. So that means we would have a linear nested if statement for grades, and it would go something like the follow. If record code equals A, then add, increment A grade counter. Else if record code equals B, then increment B grade counter. And essentially what would happen is each of those subsequent else if record code equals B, else if record code equals C, else if record code all the way down to withdraw. Each one of those would be indented either 3 spaces or 1 tab from where the previous one was. So that by the time we are all the way down at, else record code equals W, I am either 21 spaces from the left-hand margin of my page, or I am 7 indents over from the left-hand margin of my page. And then after that, we would have an end if. So this is the example we see here in the text, and it's actually one we'll kind of come back to here and there and everywhere, is the idea of nested linear selection simply by having grades. because grades, I think, make a ton of sense. The other kind of control structure we have is known as a nonlinear control structure. This would be where we have, let's say, for example, several selections we can make on the if, but only two selections we can make on an else. And I know that doesn't make a ton of sense if you think about it that way. If you look at page 39 at the bottom example, you can actually see a little bit of a nonlinear nested if selection. What essentially we're saying is, hey, look, we've put together a database. We want to query that database of different student populations. For whatever reason today, we are going to spend more energy looking at on page 39, they're looking at the different kinds of female populations that they would have at this school. So if student attendance is part-time, that's one piece of the selection. If student gender is female, that's 2. If student age is greater than 21, that's 3. Now, take action. Else, so this else, again, this is the one shown here on page 39. This else refers to the if that is student age is greater than 21. So I would have mature female part-time students is one of the kinds of data I'm looking for, and young female part-time students is the other portion of the data I'm looking for. Otherwise, the next else statement goes to the if student gender equals female. So else, add 1 to part-time male students. So you'll notice I'm looking for gender, and I am looking at age, but I am not necessarily looking for age when it's relating to male part-time students. So that's the non-linear part. I have more considerations under portions of my selection, in this case it's the female population, than I have for the considerations that I have at other portions of my selection, and in this case it's the male population. That is going to be true across all sorts of data, across all sorts of actions that you are going to be undertaking for your selection structures. So if client has balance less than $1,000, has late fees greater than $500, has current legal action, then freeze account. Else, so that's people who aren't late, who don't have legal fees, and who aren't currently behind. Leave them alone. You'll notice that is not necessarily linear, because as let's say in this case, a bank institution, I have probably far less reason to reach out to my on-time payers than I have to reach out to my not on-time payers, because clearly I want to rattle them into making future payments on time. So linear is when I have a balance, essentially. I can follow a concrete sequential line, just like your grade data would be. A, else B, else C, else D. Nonlinear is when I have it's not necessarily instability, but it's just not a 100% representation between every if and every else statement. Some might be, more involved than others, and really your business situation is going to inform you when it is that you'll use those non-linear if statements. All right, guys, last one. I know you've been patient. This has been a longer than some of our previous examples podcast. The very last control structure we have here to worry about is at the back of the chapter at 4.3, and it is the case structure. Essentially, the case structure you've already seen. It's just an alternative to a linear if structure. So a linear if is the example of your grades. If A grade increment counter, else if B grade, else if C grade, else if D grade. What ends up happening there is, and if you'll recall, think about how indented that is. So by the time we get all the way down to the withdrawal, the W case, I have 21 spaces as my indent just for the else student grade, equals W. Or I have 7 tabs for what happens there with student grade W. Now that's already way off into the right-hand side of, if you just think of like an 8.5 by 11 sheet of paper. But what happens if we have a really, really long one? So if we've got the 54 state codes, right? So we have Alabama, Alaska, etc., all the way down through Wyoming. Now I've got 162 indents if I am using spaces, or I have 54 tabs if I'm using the tab. And there's no way that fits on a page. There's no way that in any coding environment, once it is that we get to our actual developed environment, there's no way that one developer is going to be able to get to see all of those in a nice order on the way down. In those instances where we have a linear if, we can actually replace that structure with what's known as the case structure. Here in 4.3, if you look at the way the case structure looks, we have 2 keywords. Case of is one keyword, and end case is the other. And essentially what we've got is in between those 2 keywords, we would simply have case colon and then whatever it is that we're looking for. So case student grade A, increment A counter would go on the right-hand side of the colon. Next line, we would have case of whatever. And on the right-hand side of the colon, we would have, B and C and D and all the way down to F. Now, instead of 21 indentations or 7 tabs over, they're all in the same line. When it is that we've got the 54 state codes that I can send things to, instead of 162 tabs over, I've got a nice, granted long, but a nice long linear list that the next developer in the chain just has to be able to, cast their eyes straight down to be able to see. That is a huge advantage over the linear nested if. So really it accomplishes exactly the same thing. It's just that the case structure allows you to do it in a much more condensed format that's much easier to be able to rationalize your way through when you are the next developer there in the chain. So selection here in chapter 4 is a big leap forward in the complexity of our programs. It really allows us to take that step from concrete, sequential, ordered, and without alternative programs like we'd been developing in chapters 1, 2, and 3. And now we can really get some good and granular decision making on here. I want to find, part-time female students who live in the 61114 area code, who have gotten grants before, who are not on academic probation, and who are enrolled in the CIS program. That is a really granular decision that we can make now. And the way we do that is with selection. Remember, the selection keywords we have are if, then, else, and if. And we have the combination keywords and or. Remember, and both pieces of a statement have to be correct, have to be true rather, in order for the entire evaluation to be true. With an or statement, only one portion of the selection has to be true in order for the whole thing to evaluate as true. So it is more, I don't want to use the word risky, but I'm about to use the word, it is more risky to be able to use that because you have to be 100% sure that you're right. We have linear and nonlinear selection. Linear is when we have something like a grades, A, B, C, D, F, W, I, and that just makes a really nice level cascade on the way down. That's linear. Otherwise, we have nonlinear, where some selections we make have more and more alternatives, where other selections we make have fewer alternatives. And an alternative way to display the nested linear if structure is with a case structure. And they accomplish the exact same thing. It's just that where I might potentially have 162 lines of indentation for a linear nested if statement, I would have a nice, neat 54-line vertical case structure for something like selecting state codes, for example, to select on. So that is selection. In the next podcast, we are going to take a look at repetition, being able to make mistakes faster.